Welcome to the video lesson for the tangent ratio day 2. We're going to explore how we can use a tangent ratio to help us solve for missing information within a triangle. Let's go ahead and get started. If you know the length of one leg and an acute triangle of a right triangle, and you want to find the length of the other leg, not the hypotenuse, but the other leg, then you can use the tangent ratio. Looking back at our previous video for our tangent ratio, if I have a right triangle, and I call it ABC, and I know angle A, then from angle A, we have several sides, but specifically, we're going to identify the opposite side, which is one across from it, and the adjacent side, which is a side that helps form the angle that's not the hypotenuse. And those two sides we can use to help us create our ratio. So we then could say that our tangent ratio, or tangent of angle A, is equal to the opposite side over the adjacent side. And we're going to go ahead and use that ratio to help us set up some scenarios to help us solve for a missing leg. For our first example here, we want to find the value of x, and we're going to do that by rounding our answer to the nearest tenth. We're going to go ahead and use our tangent ratio, but before we start it, we want to verify we do have the right scenario. So if I look at my angle, I do have an acute angle, 32 degrees, and I have a right angle, so I know I have a right triangle. For this 32 degrees, I know that the side across from that is going to be my opposite side. Also, that x is going to be my adjacent side. And then finally, we have our largest side, or your hypotenuse. So I know that I have my opposite side, I know I have my angle, I'm looking for my adjacent side, which are both legs. So I can go ahead and apply my tangent ratio here. Looking at our tangent ratio, it's going to be the tangent of our angle. So tangent of 32 degrees is going to equal my opposite side over my adjacent side. To make things look a little similar, I'm going to go ahead and say that tangent of 32 over 1. And then to move on with this problem, I'm going to have to use a table to identify the tangent of 32 similar to what we did yesterday. So we're going to take that table, we're going to go down to 32 degrees and go over to the tangent column, and we're going to identify that the tangent of 32 is approximately 0.6249. So now my equation will be 0.6249 over 1 is going to equal 11 over x. And now that I have it set up in this format, I can go ahead and cross multiply. And we end up getting that we have x times 0.6249 is equal to 11. I can then divide both sides by 0.6249. And that will help me get x by itself. And when we're done and we round our answer to the nearest tenth, we get that x is approximately 17.6 as our final answer. All right, looking at our next example, again, we're going to verify we have the right scenario. So I have my angle of 61 degrees. That is an acute angle. I know that I have the opposite side. And I know that I'm trying to find my adjacent side, which is x. So for my ratio, I'm going to go ahead and start with a tangent of 61. And that is going to equal my opposite side divided by my adjacent side. Again, we're going to go ahead and put tangent of 61 over 1. So we have a similar ratio on both sides. And I'm going to use my table once again to identify the tangent of 61. So looking at that table, if we go down to an angle of 61 and we go over to the column for tangent, we see that our ratio is going to be approximately 1.8040. So we write that over 1, and that's going to equal 22 over x. Similar to our last example, we're going to go ahead and cross multiply now. And when we cross multiply, we get x times 1.8040 is going to equal 22. And then for my last step, we're going to go ahead and divide both sides by 1.8040. And we get x alone. And for our final answer, rounded to the nearest tenth, we get x is approximately 12.2. All right, in example 3, we're going to apply the same process. We know we have a right triangle. If I go ahead and identify sides, I have my acute angle of 56 degrees. I know that across from that we have the opposite side. And I know that 13 is going to be the adjacent side. Looking at my tangent ratio, setting up the same way we did with the last two examples, we have the tangent of 56 is going to equal x over 13. Go ahead and put this over 1. Again, we're going to look up the tangent of 56 using our table. So we're going to go down to an angle of 56 degrees, go over to our tangent column, and we identify that the tangent of 56 is 1.4826. So for my ratio now, I have 1.4826 over 1 is going to equal x over 13. We're going to go ahead and solve this the same way we solved the last two. We're going to go ahead and cross multiply. This time when we cross multiply, though, we actually are done because we get x is equal to 13 times 1.4826. And if you approximate that to the nearest tenth, then we get x is approximately 19.3. All right, your turn. Go ahead and see if you can set up our tangent ratio using this triangle and use the table to help you correctly solve for the missing side of x. So hit pause now and go ahead and try and find that value. All right, hope you guys are able to get that set up and correctly solved. If you look at our triangle, then we have the following equation. Tangent of 18 is going to equal 16 over x using your opposite and your adjacent side. And then I put that tangent over 1, so we have a similar ratio on both sides of our equation. Looking at my table, we can substitute in 0.3249 for the tangent of 18. And then from there, we're going to cross multiply like we did for our previous examples. When we cross multiply, you get x times 0.3249 is going to equal 16. Then we divide both sides by 0.3249 to get our final answer of x is equal to 49.2. Hope you guys got all that. Let's go ahead and look at some word problems or some applications of this. All right, in this problem, you are measuring the height of a tree. You stand 45 feet from the base of the tree, and you measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height of the tree to the nearest foot. So if you look at your scenario, again, you are standing away from the tree 45 feet, and you measure the angle of elevation to the top of the tree to be 59 degrees. Our question is, what is the actual height? Well, we do have a right angle here, so we can go ahead and apply our tangent ratio. Looking at my information, I have 59 and then h being the opposite side, which makes 45 my adjacent side. So I can set up my tangent ratio as the tangent of 59 is equal to my opposite side, which is h, over my adjacent side of 45 degrees. And then I can multiply both sides here by 45 to finish getting h by itself. So we now have 45 times the tangent of 59 is equal to h. And at this point, I'm going to go ahead and use my table to identify the tangent of 59 degrees. So again, go down to 59 degrees, go over to your tangent column, and we get 45 times approximately 1.6643. And if you multiply that together and round to nearest foot, then we get 74.9, or approximately 75 feet for the height of our tree. In our next example, we're going to measure the height of a lamppost. So we have our lamppost, and you stand 40 inches from the base of the lamppost. You then measure the angle of elevation from the ground to the top of the lamppost to be 70 degrees. Again, we want to try and find the height of the lamppost to the nearest inch. So the first thing we have to identify is where we are. We are 40 inches away from the base of the actual lamppost. So this is going to end up being 40 inches. And then we're measuring the angle of elevation from the ground to the lamppost. So if I make a triangle here and I measure the angle of elevation, that's going to be this angle here, because we're standing and looking up, and that's the angle from where we are to the top of the actual lamppost, and that's going to be 70 degrees. And then again, we're trying to find the actual height. We have a right triangle here, so we can go ahead and set this up using our tangent ratio. And if we do so, we have h being the opposite side, which means that 40 inches is going to be your adjacent side. So we have the tangent of 70 is equal to h, or our opposite side, over 40, which is your adjacent side. And then if I have 40 times the tangent of 70 degrees, that's going to equal my height. And at this point, we're going to go ahead and look up the tangent of 70 using our table. We're going to go down to our angle of 70 degrees and over to the tangent, and we get that it's approximately 2.7475. So I now have 40 times 2.7475, and then that's going to be about 109.9, which is approximately 110 inches if we round to the nearest inch. And that's going to be our height of our lamppost. All right, for our final example here, we have a plane, and our plane is going to be 3,000 feet above the Earth, and it's picking up a signal from an airport on the ground. The angle of depression from the plane to the airport is 47 degrees. We want to find the distance between the airport and the point on the ground directly below the plane. Okay, so here's our plane, and our plane spots the airport on the ground. So we have a line going from the plane to the airport. And then we have the flight path of our actual plane. And we know that the angle of depression, so the angle between our flight path and going down to the actual airport is 47 degrees. We also know that the height to the ground from our plane is 30,000. So if this is our ground here, then this distance is going to be 30,000. All right. We now need to try and find the distance from the point on the ground directly below the plane to the airport. So we're actually trying to find this distance here. Let's go ahead and look at that triangle a little further. So I know that I have two sides for that triangle. I have the 30,000 and I have the x. I need to find another angle within my triangle. And one thing that's convenient here, the flight path for our plane and the ground are actually going to be parallel lines, which means that we have a set of alternate interior angles with our angle of depression and that alternate angle of elevation if we were on the ground. So those are actually both going to end up being the same. So we now have an angle, we have a side, and we're trying to find the other side for our right triangle. So we can go ahead and use our tangent ratio. All right, setting it up the same way we have in the past, we have the tangent of 47 degrees. And that's going to equal our opposite side, which in this case, our tangent, our angle is down here at the very bottom. So the opposite side is going to be our 30,000, which means your adjacent side is going to be x. So we have tangent of 47 is going to be 30,000 over x. We're going to go ahead and multiply both sides by x here. Cancel those out. So we now have x times the tangent of 47 is equal to 30,000. And in the past couple examples, we've looked up our tangent value either early or later in the problem. It's up to you when you actually want to look it up. You can look it up at the beginning and substitute it in, or you can do it at the very end. I'm going to go ahead and wait and do it at the end here. So I'm going to divide by the tangent of 47 on both sides. So we have x is equal to 30,000 divided by the tangent of 47. And now I'm going to go ahead and plug in what the tangent of 47 is. So in this case, using my table, the tangent of 47 is going to be approximately 1.0724. And then if I divide those two values, then I get for my answer that x is going to be approximately 27,975 feet. All right, guys, that does it for our notes for this lesson. Go ahead and get started on the homework, and good luck.